Imagine we want to build a fragment of cone out of a sheet of paper or out of a sheet of metal, for example. And the question we want to tackle is, what is the relationship between this angle that we cut off a flat circle section and this angle that is formed by the base of the cone and the side. So what is the relationship between those two angles? Before I start solving this, I'll encourage you to try it first yourself. So first thing I'm gonna do is I'm gonna draw a side view of what's going on and put some marks and name some variables. So let's agree that green is gonna show distances, not so thick. And the red one will specify, the yellow one will specify variables. So this is gonna be angle A, and this distance is gonna be D1, which stands for diameter 1, and this one is gonna be diameter 2, as you already guessed. Now let's draw. Also I forgot to specify that this is gonna be D, this distance. And now let's draw the unwrapped version. It's gonna be a bit bigger than this guy. So it's a circle which is gonna lag a piece like this, and this one we'll call angle B. And we also know that this, as well as this is not gonna be D2. This is gonna be greater than D1, and this one is gonna be greater than D2. But we are going to give it a name. It's gonna be a bigger circle, so I'll call it D Inc 1, and D increased. Inc stands for increased, and 2. Let's make it look good. Okay, so this is done. Let me make sure I didn't forget anything. So this one is also gonna be D, since it's not gonna change when we glue this together. This distance is gonna be the same, and only these will change. Only this radius will change, or it's gonna decrease, as well as this one. Let me also draw custom angle so that I can make some marks on it while explaining some stuff. So what we are looking for is this angle. We want to know B given A. Given A, D1, D2, D, so we want to find B given some value of A, some value of D1, some value of D2, and some value of lowercase d. And let me remind you, at any moment you can stop the video and try this yourself. The first thing you could notice is that given D2, A, and D, we don't need this D1, we can figure it out. To show this, I'm going to split this like this. We get a right triangle, which means we can figure this side out, knowing this angle and D. So let's do this in the first place. Now this part is also D1. So D2 is gonna be D1 plus 2 times this, because we have it on the bottom and on top. Now let's remember the magic spell. Solka Toa, and this is meant to help us solve for this side. So we know the angle A, we know D. D is our hypotenuse. So this side is going to be adjacent to angle A. So we need something with adjacent and hypotenuse, which means we are going to use cosine. Formula is cosine of A is gonna be adjacent. Let's call this M, for example, and this one we'll call L. Yeah, so this is gonna be M over D. And we want to find M, so let's multiply both sides by D, and this D and this D will cancel, and we are left with M is equal to D times cosine of A. Let's substitute this back and substitute the value of M here. D1 is plus 2 times D times cosine of A. So this is our first. To save space, let me erase some unnecessary steps. let's frame this. This is our first help on this path to figuring out this b. Now the second step is to think about what is gonna be our d increased and the d1 increased and d2 increased. What is gonna be this diameter here and this diameter? Well, the first thing to notice is that we know that this arc length is gonna be the same as this circle arc length. Okay? If we unwrap it like this, the arc length is gonna stay the same. The arc length is gonna be let's see. We know that the arc length of a circle is 2 times pi times r. Or if we replace radius with a diameter, which is 2r, we can just write pi times d. So we know this arc length, and we also know this arc length. So let's focus on the inner circle, the inner arc. So from this, you can figure out our d increased. And we know that the whole arc length is going to be pi times d1 plus b over 2 pi times b over 2 pi times the whole arc length, which is pi times d inc 1, and all this is going to be equal to pi times d increased 1. What we can do now is move this to this side by subtracting b over 2 pi times d inc 1 b over 2 pi times pi. Oh, by the way, we can cancel pi. Can cancel pi here. D inc 1. So we are left with pi d1 is equal to this, well, cancel, pi d inc 1 minus b over 2 d inc 1. Now let's move this out. Move the common factor out. D inc 1 pi minus b over 2. And we want to find is d inc 1. And what we're gonna do is just divide both sides by pi minus b over 2. This is gonna cancel pi minus b over 2, and we are left with what? we are searching is equal to the increased one is gonna be pi, or wait, let me write it like this: d times d1 times pi over pi minus b over 2. And guess what? The same is gonna apply to the inc2. If you don't believe me, just check this out yourself. I'm just going to write this. Let me frame this. This is our second frame. Second helpful bit of information. Now let's make another drawing. We'll redraw this image but a bit differently. So this is the unwrapped version, and we're gonna have something like this when we glue the two sides, when we glue those together. And now the thing to notice is we can calculate this bit of information and this bit of information out of this, and let me put some helpful lines here. This is A, and this is gonna be our change in D2 over 2, right? And this is our change D2, D1 over D1 over 2. Okay. And what we can do now to introduce, as you can see, we have angle B here, and we want to introduce, somehow connect, figure out the relationship between angle A and angle B, which is why we want to figure out this length and subtract this, figure out this side in terms of all of this stuff. So let's do this. This we'll call it M, and M is going to be equal to D plus what is this going to be? Our D inc 1 minus D1, right? Is distance. This minus this is going to give us this over 2, right? So what is if we subtract change in D1 is going to be equal to D1 times pi over pi minus B over 2 minus D1. We can factor out D1 and we'll get D1 pi over pi minus B over 2 minus 1. Alright. and we want to subtract from it. Guess what? Changing D2. Oh, never forget that you're dividing it by 2, and we want to subtract. Same thing for the 2. Let's factor out 1/2. M is equal to D plus 1/2. D1. Let's factor out not just 1/2 but also pi over pi minus b over 2 minus 1 D1 minus D2. Okay, this looks much better. Now you might say, wait a minute, you know that D2 is equal to D1 plus 2D cosine of A, and you'll be right. Let's rewrite it, and D1 and D1 here will cancel, and we will be left with negative 2D cosine of A. 2D cosine of A. And this 2 will cancel with this 2. And we can factor out D now. D1 minus cosine of A times pi over pi minus b over 2 minus 1. Now wait a minute. And now wait a minute. You might say, you know this M already. We figured it out. M is equal to D times cosine of A. So we get something like relationship between D times cosine of A. We get something like a relationship between angle A and angle B. Now we want to somehow express B in terms of A. That's why let's simplify this expression and see what we can do. Let's add this to both sides so that we get cosine of A. Let's factor it out simultaneously. Cosine of A, 1 plus pi. We can remove the parentheses since it's not a negative sign, it's a positive sign. It's b over 2 minus 1. So 1 and 1 will cancel, is equal to 1. Right? The 1 here will stay. So let's multiply both sides by this business. Now we want to solve for b. So let's multiply both sides by 2. We get 2 pi cosine of A is equal to 2 pi minus b. Now let's add b to both sides, and subtract 2 pi cosine of a from both sides. And we get b is equal to, from this side, 2 pi minus 2 pi times cosine of a. We can factor 2 pi out, so b is equal to 2 pi 1 minus cosine of a. And we are done. And now let's write all of our framed formulas we figure out at one place. And what we can do now is, maybe if we substitute b in here, we can cancel some stuff out. Let's try doing this. Let's try doing this. d1 times pi over pi minus, let's see, we have 2 pi here, and we can cancel 2 at the same time as substituting it, so we get pi times 1 minus cosine of a. Okay? And guess what we can do now? We can factor out pi and cancel it out with a pi on top in the numerator. Pi 1 minus all of this business minus cosine of a. Okay, one more, cancel, and we forget d again, d1 in the numerator, and we are left with d1 over 1 minus 1 plus cosine of a. Oh, let's see, this cancels out, and we are left with d1 over cosine of a, which is much simpler. Now this gives us full control over how we want to design our conic fragment, our fragment of cone, how we want to design it. We can express, for example, if we want to know d1, we can just express it in terms of everything else. We can also express a in terms of everything else. It's going to be our cosine of something, and we can express whatever else we want to know. We can express d if we wanted to, and we could express a here as well. Could express a here, express a anywhere we want. So we have the full control over the shape of our cone fragment. It's not a section, it's a fragment or a piece of cone. So in other words, knowing the relationship between B and A, D2 and D1, D2 and D, and everything else, we can design whatever based, for example, if you want to build a rocket, we want to have a cone fragment here. Then it's going to continue. For example, we don't know this diameter, we only know this diameter and the angle we want here. This is going to be A and this is going to be D2, and we can figure D1 using this formula. Also this is going to be D. We can figure out D1. We can figure it out. It's going to be D2 minus all of this business. Using this formula, we are going to find the angle we need. To perfectly match this A angle, and also the diameters for this circle. We'll find using those two formulas. There you go. We are done.